Over the last few years, enterprises have poured roughly $30 to $40 billion into generative AI infrastructure. In the summer of 2025, MIT's Project Nanda audited 300 public AI deployments to see exactly what that capital bought. The results briefly dented the stock prices of NVIDIA, Palantir, and Oracle. This chart illustrates the divide. Out of all that investment, 95% of enterprise generative AI pilots delivered no measurable impact on profit and loss. On the right side, a small minority, just 5% of integrated pilots, extracted millions in financial value, creating a tangible return. The companies extracting those millions do not have access to secret, superior algorithms. They are buying the exact same baseline technology as the failing majority. Instead, they execute a strategy focused on fine-tuning smaller models, allocating the bulk of their budgets to human upskilling, and building governance natively into the architecture. Winning in enterprise AI requires an inverted operational strategy that prioritizes specific execution over technological hype. For years, system architects operated on the assumption that high accuracy required paying by the token to rent the largest frontier model available. This chart of toolbench pass rates challenges that assumption. A fine-tuned 350 million parameter model achieves a 77.55% success rate. On the same task, ChatGPT scores 26%, and Claude manages under 3%. A small model, explicitly trained on your specific vocabulary, learns exactly what your internal data means. It outputs the rigid format required for the job, every single time, without having to guess from context. Consider Conversa. They score customer service agents by analyzing millions of hours of call center recordings every month. They replaced OpenAI APIs with 60 lightweight adapters running off a single open-source meta model. They cut operational costs tenfold, dropped inference to milliseconds, and boosted accuracy by 8%. This diagram shows the hybrid router pattern. Incoming queries hit a classifier switchboard. 80 to 95% of routine requests route to a fast, fine-tuned small model, returning answers instantly for pennies. Only the complex 5 to 20% escalate to a premium frontier model. Frontier models charge $4 to $5 per million tokens, whereas running a localized, specialized small model costs a fraction of that. True architectural scalability comes from capturing massive economic savings where volume lives, reserving expensive computational power exclusively for the hardest logic problems. Optimizing the server architecture addresses only a small portion of the actual implementation. Boston Consulting Group tracked where AI value originates. 10% of the total value is derived from the algorithms and model itself. 20% comes from data and technological infrastructure. The remaining 70% of value is generated by people, process, and upskilling. Researchers at MIT identify the failure to manage this 70% as the learning gap. This gap explains why 19 out of 20 enterprise AI projects fail. Organizations frequently purchase a sophisticated tool and expect it to yield magic, while neglecting to teach their workforce how to actually integrate the system into daily operations. Morgan Stanley avoided this by focusing on the training and workflow integration of 20,000 wealth management advisors, ensuring the tool actually solved the friction between knowledge and communication. By collapsing document retrieval times from 30 minutes down to seconds, they achieved a 98% adoption rate across their teams. In this context, the weekly active user adoption serves as a leading indicator of whether the project will eventually reach its financial goals. Algorithmic perfection yields absolutely nothing if the organization guarantees failure by starving the human workflow integration of capital. Beyond performance and adoption, there is a legal reality that turns AI implementation into an exercise in risk management. When an Air Canada chatbot invented a fake bereavement policy and New York's MyCitybot dispensed illegal business advice, tribunals rejected the defense that the software was an independent entity. The legal consensus is clear. Your enterprise assumes liability for whatever your algorithmic agent states or promises. This liability compounds with the enforcement phase of the EU AI Act. Penalty thresholds reach up to 35 million euros, or 7% of global annual turnover, figures that make past GDPR fines look small by comparison. True protection requires proactive, systemic governance built into the data flow rather than a reactive policy document. In Salesforce's structural governance blueprint, a customer prompt hits a data masking gate, replacing identifying text with generic tokens. This protects proprietary information from the language model. The output undergoes a verification check against corporate data, generating an audit log before releasing the final response. Embedded governance acts as the structural chassis of the system. It allows the enterprise to operate at maximum velocity without risking legal exposure. To cross the divide, organizations must pivot away from the tactics that trap 95% of the market in pilot purgatory. The successful 5% follow a three-part architecture mandate. First, replace expensive APIs with fine-tuned models. Second, direct budgets into workflow training. Third, hard-code NIST-backed governance. The baseline algorithmic tools you use are commoditized. Every competitor has access to the same capabilities. Ultimately, success depends on fitting the right model to the precise problem, rather than simply renting the largest parameter counts. The Gen AI divide persists today because of a lack of institutional discipline. The ultimate competitive advantage remains in execution.